So I told you that of all the things we're going to do in this class, the scientific method is the most important. So we kind of did just like a general overview of the scientific method, but we're going to dig a little deeper into three of the things that almost always come up on the test. So the next three classes are going to be about that. So today we're going to talk about those hypotheses. We're going to be hypothesizing today, which sounds like more fun than it is. They love to ask questions about the hypothesis, and when I see students' answers, it shows me that they have a really shaky understanding of what a hypothesis is, because a lot of students will choose multiple choice answers that just don't even make sense. That being said, we're going to dig deep into that, and then the next two classes we'll do independent and dependent variables, and then we will look at designing and improving scientific experiments, because they love to ask you questions about how an experiment could be improved. And again, if you only have a shallow level understanding of what an experiment is, you'll have no idea how to improve it. So let's start digging a little deeper. I will just remind you that hypothesizing is not, some people call it an educated guess. That's not really enough for me. I like to be a little clearer. Yes, we are making educated predictions. We're making a prediction when we have a hypothesis, not asking a question, making a prediction. So we talked about these 4 traits of a good hypothesis last class. If it doesn't have these 4 traits, it ain't a hypothesis. First trait is it's educated. I mean that before you form your hypothesis, you were observing, you were questioning, and you were researching. All that first step we talked about last class, where we wonder, we look at other scientists' research. We don't just go in there making guesses and we haven't even looked at what's going on. That's that idea of educated. And then we said it makes a prediction. And an easy way to make a prediction is to use an if-then statement. Not the only way, but an easy way. We said it's testable, meaning we said that there is some experiment we can design. And like we said before, it's falsifiable. There would be some outcome to our experiment that would prove our hypothesis wrong. This is just an overview. Let's go into detail. We already kind of said this, but our hypothesis has got to be educated, right? Come after we observe. Guys, just humor me. Remind me what the word observation means.
It's like the 5 senses, right? You're touching, smelling, seeing, tasting.
Yeah, using the 5 senses to take note of what's going on or to look at a phenomenon. I keep using these same words like I want you to know them when they come up on the GED. And I know questioning is an obvious word. We're asking questions. But the research is important. Good scientists do build on the body of science that's already out there. And this is what too many students forget to do when they go to form hypotheses. So again, if it doesn't make a prediction, it is not a hypothesis. Please, 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 please stop picking in your multiple choice answers questions as hypotheses. It cannot be a question. It has to make a prediction. It has to be something that we could look at it and afterwards we could say, oh, that's true, or oh, that wasn't true at all.
Do they all have to say if and then?
If then is not required, but what if then is, it's a really handy way to kind of test if you're really writing a hypothesis. So for example, I could have a hypothesis that says the faster I talk, the more Francis will cry. I've written a hypothesis. It's based on my observations as a teacher. I'm looking around, I'm talking fast, people are bursting into tears all over the classroom. I'm reading the research, all the other teachers are saying it's true. So I have this hypothesis here. It makes a prediction. There is a prediction between these 2 variables. We're saying that if I talk faster, Francis is gonna be more likely to cry. That could be supported or refuted by the data. I don't have to have it in an if-then format. However, I could take it and put it in an if-then format, and that often helps students to test if it really is a prediction. Like, if I talk faster, Francis will be more likely to cry.
Or confused.
Well, it would be hard for me to measure confused, but I can easily measure the volume of your tears, you know? Just put a little vial under there. But you see, I mean, I'm making a joke, you guys. But the idea here then is I can test out if that hypothesis really is a prediction by using that if-then format. Another benefit to the if-then format, even though it's not necessary, is it helps students with independent variable and dependent variable, because the if is always the independent variable, then is always the dependent variable. If the independent variable, then the dependent variable.
So that's always true. It's always the independent variable first, and then the dependent.
If you have it in that if-then format. But I don't have to write it in an if-then format. So I could have said, Francis will be more likely to cry if I talk faster. So that didn't come first. The independent variable came second that time. So that's why being able to put it in an if-then format can help you get those two straight. So we said last time as well that this hypothesis had to be testable. If I can't test it, it might be a great idea, but it's not a hypothesis. I should be able to design an investigation to test the predicted relationship between the variables. I ought to be able to see what happens when I do expose something to an independent variable, if it does indeed produce the outcome I was expecting with the dependent variable. And then finally, we said that it has to be falsifiable. And again, this is that one that everybody mixes up. Like, what? My hypothesis is supposed to be false? No, it's not that it's supposed to be false, right? It's that there is some possible outcome of your experiments. There is something that could happen in the experiment that would make you say, oh, no, I must have been wrong. I could keep talking faster and faster and faster and faster, and no matter how fast I talk, Francis just won't cry. That is a falsifiable hypothesis. There is some possible outcome to my experiment that would prove my hypothesis wrong. So it doesn't mean it's wrong. It just means that it's not absolutely for sure 100% right. So there's a possibility of getting results that prove the hypothesis wrong.
So is there a word or a term that you use if it's continually tested and it's correct all the time?
Oh, like the data just keeps supporting and supporting and supporting and supporting the hypothesis?
Yeah, regardless of who tests it.
You just want like a specific word?
Yeah, I didn't know if there was or no.
Yeah, like we say it's proven or something like that. Hold on, we have a guest speaker. What do you say?
You can't really say that the hypothesis is true. So what you say is you fail to reject that hypothesis.
This is what fancy college students say. You ready, you guys? We fail to reject the hypothesis. This is how afraid of commitment scientists are. You can never say it's proven true. Yeah, you want to come over, Nicole?
Can I come live with you in the fall when I take science?
You actually might want to just live with my college student, Ruby. She lives in Mesa, though. So that's good. You can escape all your children. You can go down and live in Mesa with Ruby, drink a lot of tea, and talk science. Okay, so let's practice. Let's start writing some hypotheses. So I don't know if you guys noticed, but a singular is a hypothesis. But multiple, plural, if I'm writing more than one, those are hypotheses. It just changes from an I to an E.
Oh, no way.
So it's not hypotheses, okay? It's hypotheses. My first observation, because remember, we start with observation, questioning, and researching. So I observed that my morning class retains more math than my evening class. I wonder if this has to do with the amount of natural light in the room. So I have this observation. I'm noticing that something affects something else. If I want to write a hypothesis, I need to write a prediction about how the independent variable will affect the dependent variable. So let's go looking through this little observation of mine. What are these variables that I think are interacting with each other, you guys?
Natural light and darkness?
The amount of natural light as compared to darkness is one of the variables. It's the thing that I think is doing the affecting, how much light or darkness is in the room. But there's another variable, the thing I think is being affected. What do I think this light is affecting?
How much people
Retaining more math.
There you go. My class is retention. So when I do my hypothesis, it has got to make a prediction about the interaction between these two variables. So when I go to hypothesize, shall we use the if-then format since it makes it a little simpler? Let's say if there is more natural light in the room,
then my students will retain.
Yes. Now, this word retains a little vague. So I think as I go to write my hypothesis, I'm going to really probably hone in on something I could measure. So let's see, what am I measuring when I do retention? I'm measuring memory, right? So maybe I'll predict that they'll do better on a memory test. So students will perform better on a memory test. Now you might say, Kate, we were talking about retention in math, and that's true. But if I'm really testing retention retention, I have to think about how am I going to measure retention? And so that was the way I chose. And certainly this is not the only way you can write this hypothesis. But notice that I was really specific. I can measure both of those things. I can measure the amount of natural light in the room. I can measure the results of a memory test. The GED test is generally a multiple choice. There used to be 2 short written answers on the test where you had some freedom, where you wrote about a paragraph, but they actually took those off the science test. So now it's going to be all multiple choice, matching, putting things in order, those kinds of questions. So you wouldn't have to be able to craft your own, but you would be able to have to recognize a strong hypothesis in the multiple choices.
In there is a independent and
the if and the then. So the if will be my independent variable, so an increase of natural light in the room. And then the dependent variable is going to be how I think that it'll be affected. So that's the then. So the student's performance on my memory test.
So an independent variable could be the cause and the dependent could be effect.
Yeah. And you know how I don't like to say the words that your hypothesis is right and wrong. Similarly, scientists are a little afraid of saying the word cause and effect, because just because 2 things happen together doesn't mean that one is a cause. So this is actually really, really important to your science class, Nicole. So write this down. They will often say to you that causation is not the same as correlation. Correlation is not causation. They might say it either way. But you need to understand the fine distinction between causation and correlation. Now, this isn't super tested on the GED because this is a finer point of science, but it is a huge deal in your college science classes. So causation means that one thing makes another thing happen. Correlation just means that things occur together. Causation is like a stronger word than correlation. So I'm going to give you a really famous study from the world of education, because I was an education major. I have a bachelor's of education in secondary mathematics. And one of the studies that they've done is a correlation study between students' grades and how green their lawns are. There is an extremely strong correlation between the green of your grass and the student's grades. It is a very strong proven correlation. If the grass in a house is green, the students are more likely to have good grades. So I want you to think about that.
To the grass all the time and they're just like really good workers.
Well, that's what I'm saying. Do we think the green grass causes good grades? No, I don't either. Do we think the good grades cause the grass to get greener? Your child brings home an A, your lawn gets a little greener? No, I don't have any causation there. And yet there's a very strong correlation.
It's
and
work
so, you know,
ethic, right? It would be work
it might exactly. Researchers predict that there's some other third thing out there somewhere that affects them both. So it could be work ethic. It could be money. If you can pay the landscaper, you can pay for the private tutors. We don't know exactly what it is, but there's definitely a correlation. Those 2 things can be shown to be related. So sometimes it's just a correlation, not necessarily causation, but using that word cause, Nicole, can really help you pinpoint down which one's the independent and which one's the dependent variable. So I just want you to have in your minds to think of it like a cause. The independent variable is like the cause. It's like the first thing that happens. And the dependent variable is like the effect, even if it's not quite that strong of a relationship. That will help you sort out which is which. A very long answer to a very simple question. You're welcome, you guys. So let's look at Lynette then. Lynette notices that she is usually really hungry after her math class. She wonders if her blood sugar drops at a faster rate while doing math than in other classes. So again, we are observing something, observing a phenomenon. We're wondering, we're questioning. Now, if Lynette was doing a good job, she'd also go ahead and research this. But we need to make a hypothesis now. So again, let's go back and look. For it to be a hypothesis, it has to be a prediction about the interaction between these 2 variables. So what are our variables that Lynette is looking at here?
Blood sugar
dropping and hunger.
I think blood sugar dropping and hunger are the same thing. So what do I think that her blood sugar dropping is either affecting or being affected by?
Work, like doing math problems.
There we go, doing the math problems. She thinks that it's being affected by the class she's in. She says that when I'm in math class, my blood sugar drops faster. Okay, so it seems to be that she's thinking that the type of schoolwork she's doing is affecting her blood sugar dropping. Let's try it with an if then. Which one do we think is because? I just gave you a whole lecture about how it's not really cause. Which one is kind of like the cause here? The one in control.
Class is the cause.
There we go. So if Lynette is in math class,
then her blood sugar will drop
faster. She thinks it's just a rate thing. Then her blood sugar will drop faster. And she's comparing it to her other classes. So let's be specific. Then her blood sugar will drop faster than in other classes. The independent variable is the class she's in. The dependent variable is her blood sugar. She thinks her blood sugar depends on which class she's sitting through. I just was watching videos before we got onto class to look for people who explained experimental design well. And on one of the videos that did a little thing I liked, when he looked at the words independent and dependent variable, he said the independent variable is the thing I change. So like Lynette says, I can change what class I'm in. Lynette can go to math class or go to English class or probably go to the beach. And the dependent variable is what gives you the data. He said, I change which class I'm in, and then the dependent variable is the data, my blood sugar level after I change my class. One more trick to help us remember. So next one, I'm totally being a brat. Now I'm gonna make you guys think. I have a you notice, you wonder. I want to come up with one on our own besides Kate, Kate's morning class and Lynette and her math class. Mine always involve gardening or class. Because those are the things I'm looking at and wondering about all the time. You notice any kinds of weird things you've been noticing lately? What's been going on that's had you surprised?
The media pushing fear-based, I don't know.
Yeah, they do seem to be into that lately, huh? So
yeah,
the media
causes people to be fearful and go out and panic buy when it's not even appropriate.
So then we're going to wonder about how one thing affects another then. And we're going to try to get a little more specific. So yeah, the thing you're noticing is kind of big and general. So we should kind of pinpoint it in here. If we're going to do a hypothesis, we should wonder, what do you really wonder? I mean, what aspect of this are you wondering about?
Panic buying.
Okay, the buying. So you think that the way the media treated the coronavirus led to the shortages we've been having of goods, the panic buying? Is that what you mean?
Yeah.
Okay, so we wonder if news coverage of the pandemic affects how people purchase goods. Okay, so I still haven't gotten to my hypothesis. I'm just kind of narrowing down in on this wondering here about these two variables. So we definitely have this interaction here of the news coverage and the people purchasing goods. But when I go to write a hypothesis, let's remember that we had said that good hypotheses are pretty specific. News coverage is just such a general term still. So I'm going to ask you to hone down in on it even a little bit more, Sarah. What aspect of the news coverage? Do you think it's the amount of news that people watch? Do you think it's the news channel? Do you think people who watch, I don't know, CNN are going to purchase more toilet paper than Fox News? What specific aspect of the news coverage do you think we should hone down in on and test? Now, it doesn't mean that's the only thing making an effect. It's just that we've got to narrow it down in order to do a good test. That's two really easy.
Someone watches more news, then they are more likely to go out and panic buy.
So if someone watches more news, okay, so I'm going to say if people watch more news, because I don't just want one person. I want a group of people for a good study. Okay, so if people watch more news, then
they are more likely to go out and panic buy.
When you say panic buy, again, hard to measure. So do you think that their monthly buying is going to increase? Do you think that they are going to buy more frozen goods? I mean, can you really hone in on one avenue of that panic buying that I could measure? Do you just think they'll spend more money on groceries each month?
Yeah, I mean, or toilet paper and sanitizer. People are crazy over that.
Okay, sure. I'm going to pick one. They will be more likely to purchase toilet paper. And see how I took that time to really hone in on two things that I could measure, even though I know this is not the full picture of what's going on. I know there's hand sanitizer too. I know that people keep buying out the friggin' ice cream, so I can't even get a gallon of ice cream. But these are two variables I can very easily measure. I could have said they will spend more money on groceries each month. That would have been more general and easily measurable, but I really needed to pinpoint it to something that could be true or false based on my research. Because the panic buying thing is hard, because then someone might say to you, I wasn't panicking, I just needed more toilet paper. Good. I'm glad for the work we're doing on that one, because I think it's going to help you to be more picky as you pick the best hypothesis when you go to take the test. So guys, I know you want to remember this for test day. So the important thing, practice, 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 and we'll see you next time.